Okay, let's continue our review for the Unit 1 lecture exam in astronomy by talking about Albert Einstein's contributions to planetary orbits. And so we started off by talking about Ptolemy and the idea of the geocentric universe. And then we talked about Copernicus and the heliocentric universe. And then we talked about who Galileo was and his contributions to planetary motion. And then we talked about Kepler's contribution. And then we talked about Sir Isaac Newton's contribution. And so Sir Isaac Newton lived about 350 years ago. And so for the past 300 years or so, we thought that Sir Isaac Newton's way of describing the universe was the correct way. And so he described the motion of objects by using the law of gravity, so that the force of gravity depended on the mass of object 1, the mass of object 2, and then divided by r squared. And so by using this formula and his 3 laws of motion, he was able to predict the orbits of planets going around the sun. Well, it turns out that this is really not the correct way of viewing the universe. The correct way is by using the concepts of relativity as proposed by Albert Einstein. So you can see Albert Einstein comes up with his special theory of relativity in 1905. And this theory is going to explain how space, now space is going to be length and width and height, so 3 dimensions of space, and time, and mass, and energy change in a frame of reference that is moving at a constant speed relative to another one. So like, for example, I'm on Earth and I observe a rocket ship traveling past me going at a certain speed. So its speed would be constant relative to me. And so this particular theory is going to explain how I am going to view space and time, matter and energy. So the next thing is that space and time go together to make 4-dimensional space-time. So we actually live in 4 dimensions, not 3. And then according to a stationary observer, so here I am on Earth, I am going to notice that that rocket ship, as it travels past me, is going to be thinner. It's going to be contracted. If I look at a clock on that rocket ship, that clock is going to be running slower. And the mass of that rocket ship is going to be increased because it's moving at a certain speed past me. Well, Einstein wanted to go further than just objects traveling at constant speeds. He wanted to know how would things look in a frame of reference that is accelerating. And accelerating frames of reference go with gravity. Because do you remember, when I take this pen and I drop it, it accelerates. Its speed changes as it's falling. And so accelerations are caused by gravity. So this new theory that he came up with for accelerating reference systems incorporated gravity without having to use this formula. So this formula is an approximation which is pretty good at explaining how the universe works, but it's not really the correct way. The correct way to view the universe is always by using general theory of relativity. And it's very complicated. So it requires the usage of 10 equations that have to be solved at the same time using calculus and written in the form of a tensor, which is a multi-dimensional structure. But the main thing I want you to see is that the mass of a star bends space and time. So space and time are 4 dimensions. Mass causes a curvature in space and time. A planet will follow that curvature. So you've seen at a mall a yellow thing that you put pennies into, and then when you put the penny in there, what happens is the penny goes around and around and around, and then finally it goes down the hole in the bottom of that thing there. So notice that the penny is following the curvature of the plastic. So similarly, if you have a very massive object like a star, then that star is going to bend space and time, and then a planet will be following that bendage in space and time. And that's the real reason why a planet goes around and around. It's not because of this formula. So this is an approximation for what really happens, the bending of space and time. Okay, so that completes this review for this particular lesson. And so hang on. So now we're going to start talking about light in our next review video.